So I'm going to pause here for a second, just talk about the design process. You probably know the traditional design process, I've just described it. Act 1, architect, client, developer, whatever. Act 2, structural engineer comes here. Act 3 goes out to tender, competitive tender, right? So this is the traditional design process. So we don't have a lot of input into we don't have a whole lot of input into the design. So this is the schematics that we were given and the sketches. And this is us. We start in stage 0. We start with structural massing. So we determine where the zones for the structure can go, right? So we determine where the zones for the structure can go. So so from this you can see that we have spaces where we can put structure. That's basically what it is. We have a timber. Lost it. No. Okay. So we have a timber first policy. So we do this in Rhino, and the original sketches we render in timber, just to remind ourselves that we should probably be looking at timber before we look at any other material. So here we are. This is our first attempt with all timber, right? Timber, so timber rafters, timber ridge beam, and a timber cranked portal frame, right? Timber cranked portal frame. Okay, that should ring alarm bells for you, right? Because that isn't a thing, right? Cranked timber portal frame. I reckon each one of those would probably be $25,000 to make, right? So kind of thinking, and remember it's all about stability, which I'll touch on in a second. So these are the three, we had 3 challenges here. The number 1 was the operable doors. And if you remember the operable doors, they come with a strut that operates, and they wanted them to disappear as the doors opened, right? But the closer you get together, the bigger the load is that pushes back on the strut. And we wanted them really close. So the loads that are pushing back on the strut, which you can see over here, are massive. And we thought timber really doesn't suit that kind of thing. So we thought for the operable doors, we'll do steel. Second challenge was there's a massive plant room in the middle of the building, open to the elements, right? This is right on the water, open to the elements, heavy loads. Probably doesn't suit timber either. So we'll do the operable door sections as steel, and we'll do the plant room as steel, right? And the third one is my favorite topic, lateral stability. This is an excerpt from AS 1684. So AS 1684 is 250 pages long. Every page counts. Lovely read. 50 of those pages about lateral stability, right? Or bizarrely, what they call, I had to go at the council on the 1684, I said, what they call racking and shear forces in bracing. It's like they ran out of words to use to describe, but it's lateral stability in our mind. So, but they call it something else. I don't know, maybe lateral stability wasn't a thing, I don't know. But, so it's about holding this building up. So it's about the cardboard box again without any ends, right? Now there's 2 different types of lateral stability. There's core diaphragm and there's distributed frame. And I won't spend too much time on this. But core diaphragm is where you have a concrete core. So this is the Burj Khalifa. I had the joy, not so joyous time of being able to work on the Burj Khalifa when I was at Haida. It's a concrete core. So it's a buttress core, special buttress core, done by a very specialist engineer in the US. Distributed frame, anyone know what the structure is for the Empire State Building? Steel, all steel. Any bracing? Any bracing? No bracing. It's all welded it's all welded? It's all bolted portal frames. Apparently, they didn't have computers back then, or kind of. Apparently, it's got massive capacity with lateral stability. It could take another 50 stories. Because they didn't know what they were doing, so they just overdid everything. But now, well, look what I found. So here I was writing this seminar, and I was like, core, I wonder what else. And I thought everything needs stability, right? And I looked around, I had these 2 tables in my office, and it's like, just a second. One has the core diaphragm, and the other one has a frame distributed. Anyway, how bizarre is that? So we started moving away from a full timber building, unfortunately. So remember, last week, here I am presenting to the Timber Design Awards, and here I am moving away from timber, and it gets even more embarrassing. So here we are. Then we ended up being full steel frame. And here it is during construction. What a great spot. Look at that. And there it is again. I just wanted to show you the doors opening again and the lateral stability. Okay, final building. First Steps Counts, Taree. Anyone know and love Taree? This is with Austin McFarlane, architects, Walter Dubber, the builder, and Caroline Pitcock, regenerative design guru, really. Living Building Challenge. The Living Building, do you do Living Building Challenge? No. This started as a Living Building Challenge, but it ended up getting abandoned because it's so onerous, and we couldn't satisfy the water pedal. It's just, EPA just got in the way, so we abandoned it completely, but it still has its principles.